All right, good morning, everyone. We're not going to do anything new today. We're just going to do practice with differential equations. Okay. So we have 4 problems to do today. We'll just get that practice in with all the steps. So this is off of today's worksheet, but I'm going to do this a little bit out of order. I want to do problems that are more familiar first, because things involving other variables that are other than x and y will save until the end. The same process, we just have to kind of get used to looking at variables that are not x's and y's. So I'm going to start with number 2. Okay, I'll write this a little bit larger, make it easier for you to see. So y prime minus y prime minus xy cosine x squared equals 0. Let me summarize the steps that we're going to take, and then we can practice with each of the steps in turn. So the first thing that we want to do is we want to get this to be more descriptive, right? So y prime, we're going to rewrite as dy dx. Next step, we want to eventually get 2 fractions to be equal to each other so that we can cross multiply. And when we cross multiply, it doesn't separate the variables for us, but it does get the dy and dx set in their correct locations, right? We want the dy on the left, we want the dx on the right, we want them to be in the numerator position. And then from there, we can decide if there's anything else that needs to move. Are there x's that needs to be moved over? Are there y's that needs to be moved over? And then once we have full separation of variable, then we can begin to take the integral. Okay, and as we take the integral, today we're going to see things that are a little bit more involved because we may have to use substitution to solve the more complex integral problems. But once we get our antiderivative, then a plus c is going to show up, and then from there we got to decide, do we solve for y first, do we solve for c first? And we have kind of 2 general guidelines to help us decide which is going to be the easier path depending on the situation. Okay. All right, so let's look at number 2. Okay, so first things first, I'm going to get that dy dx to show up. So y prime, if I see y prime, I'm going to rewrite that. Next step, I would prefer to get my 2 fractions on either side of my equal sign. So I'm going to add that xy cosine x squared to the other side. And as I add it to the other side, I'm just going to put a 1 underneath it just to make it easier for me to see my next step of cross product. All right, questions so far? Now, as I cross multiply, I'm going to strategically choose the side that's going to give me dy, right? So I want to get that dy on the left and the dx on the right. That's my initial goal. So cross product here. Cross product there. Okay, our dy, dx are nicely in their correct positions. So now we got to take a step back and ask ourselves, do we have full separation yet? Okay, we're one thing away, right? What do we need to do?
Divide by y.
Okay, divide by y. Now, when we divide by y, is it going to be y dy?
That'll be 1 over y dy.
Good, in the denominator. So I just want to point out these things that I see year in and year out. Is when students divide it over, I think there's a a sense that they're doing something wrong, or it doesn't feel comfortable to leave that y in the denominator, so they move it up and then make it y dy, and that just ends up, students starting at the wrong spot. Okay, so don't be afraid to leave the y in the denominator because we have a rule that can handle that, right? So if that's where it ends up algebraically, then that's where it's supposed to be. All right, so now I have dy over y is equal to x cosine x squared dx. Okay, let's take a look again. Full separation. Okay, now we have full separation, right? Just double check we do. All right, going to involve the integral sign. The left side, if you can recognize that as just 1 over u du, then we can tell that this is just going to be a nice application of natural log. So that's pretty easy. But the right side, what do you notice about the right side? Is there a rule that we can match, and what process do we have to go through?
And cosine is sine.
Good, so we're targeting our goal, but we see it's a little messier than what we have with our rule. So in order to get this paired down to what the rule says, we need to go through a bit of u substitution. So u equals x squared. I'm going to go through my full process here. Divide the 2x over, isolate the dx. Make my substitutions. All right, what's going to go away cleanly for us? X's, and the leftover what in front? 1/2, right, okay, good. So we're on our way to getting the right side ready for our integral rule. I'm just going to have my left and right side be at the same spots, so I can just take the integral all at once. Makes it cleaner. And also easier for you to double check your work if you can line everything up nicely. So both sides are ready to go, right? I did a little bit of cleanup on the right side to get it ready, but left side is just a nice clean natural log rule. Right side is a nice clean cosine becomes sine. Okay. No need for u substitution on the left side. I might just replace my y in terms of, or replace my u in terms of y here. One half stays, cosine becomes sine. And while I'm at it, I'm just going to go ahead and replace the u in terms of x squared, just to save an extra step. Okay, questions so far? We still have to solve for y, we still have to solve for c, but at this point, you've done the majority of the work. You've earned most of the points. If you mess up after this, it's just minimal points. Okay. So this is the most important part to get to this point here. That's what I'm looking for, and that's what on the AP exam as well. They'll award the most points up to this point because after that it's just cleanup. Okay. Any questions here? Okay, let's reset. I'm going to put this at the top of the page here. And we're going to talk about the cleanup process. Or working our way to our specific solution. Now, it's asking for a particular solution, which means that we have to solve for C, but I want to solve for y first because of the situation that I'm in. There's a natural log in this problem. And the way natural log works is the C, after we clean this up, the C is going to end up absorbing all the mess around it, and it's going to clean up nicely. So I prefer this to be a little bit cleaner before I solve for my C value. So that's typically, for me, I think the path of least resistance. If I solve for C earlier, I got to keep track of more things. I got to deal with a natural log, and it's just more work, I feel. So I'm going to solve for y first, and then after I get this cleaned up to be a general solution, I'll worry about that order pair. All right, so what can I do to get that y by itself? Yeah, we know that natural log has an inverse function of e, so involve exponential function e. We can use that to help us clean up that left side. But again, we only involve e if we see natural log, right? We don't just automatically use e just because we see it in problems. It's with the sole purpose of trying to get that natural log to go away. Okay, so this cleans up nicely to be just absolute value of y. Now the right side, how can I separate the c away from this expression? Okay, so e to the 1/2 sine of x squared, but initially I'm going to say it's multiplied by e to the c. And again, I just want to show that we're basically applying the property. If I have a to the m plus n, I can split that up into a base to the exponent times the same base to the other exponent. So I'm treating the m as the 1/2 sine x squared. I'm treating the n as the c, and the e being the base. I'm able to cleanly separate it in a way where I can then isolate that e to the c and just call it what? Just c. But now it's not being added, it's being multiplied. So that's one issue that I see students have. They want to bring that plus sign down, but it's no longer a plus, it's now become a multiplication. Okay. We can draw that c out in front. Notice that it's already looking cleaner than before. I'm going to drop the absolute value, but as I drop the absolute value, I need to balance it with the plus or minus c. And what does plus or minus c become? Just c, right? Because c represents positive numbers. It also represents negative numbers. So plus or minus c is just c. We'll just let c absorb all the positive and negatives, and it gets to be a very clean equation, much cleaner than before. And I would rather solve for c here than solve for c here. Okay, there's my general equation. Now I'm going to involve my order pair. To solve for c. And that will take me to a specific solution. Okay, so e goes in for y, 0 goes in for x. Okay, what does sine of 0 become?
0.
Just 0. E to the 0 is 1. Okay, anything raised to 0, anything raised to 0 power is 1. So e is equal to c times 1. So that means c is equal to e. Okay, we're going to update the equation where we initially made the substitutions for x and y. The equation looks a little strange. It's just e times e to the 1/2 sine x squared. So it looks like we're just replacing a letter for another letter, but we're replacing a general constant with a specific value. Right? E is a specific number. So this form is fine, but I also want you to be aware that another way that can be written is combining the e's together, and there's a hidden 1 above it, so we can also think of it as e to the 1 plus 1/2 sine x squared. Either form is fine, but I want to show you this other form because if it was a multiple choice question on the AP exam and you got to this answer, but the answer choice is showing this, I want you to be able to see the fact that your form may be written a different way and to be able to recognize that other form. Okay, it's a long process, right? But we're just kind of taking the steps that we learned from before and adding a little bit of complexity involvement with U substitution for the right side. Okay, questions? Okay. Let's look at number 3. I'll write this a little bit larger. So I want you guys to take the initial steps, right? Can you do the parts leading up to the separation of variables? So the dy dx, getting the 2 fractions to show up, cross multiplying, separating the variables, and then we can work together from there to take the integral. Okay, let's check our steps leading up to that point. Initially, get that y prime to show a dy dx. After that, move the negative term to the other side so I can get it ready for cross product because of my denominator. So as I move the x dy dx to the right, I'm also merging it into one fraction, and I'm just making that left side with a 1 in the denominator. Okay, cross multiply, but as I cross multiply, I'm going to target my dy first. So whatever has a dy is going to be on the left side. So I'll do x dy first, and then the other side being the y natural log x to the 4th dx. Okay. But that's my initial goal. I want that dy and dx to be in the right positions. Okay, so now we can take a step back and look, is there anything else we need to move? Yeah, the x is out of place, needs to be divided to the right, and the y is out of place, so we divide it to the left. Again, we have to just be comfortable with the fact that if a variable ends up in the denominator, that's where it's going to stay initially. Okay. All right. So we have the y swapping places with the x divided by y, so I have dy over y, divided by x, so I have natural log of x to the fourth over x dx. Full separation is achieved. We're now ready for the calculus portion. Now, something I do want to bring up is there is actually a better place where we can place that 4 to make it easier to work with. Where can we put that 4? What log property do we have available to us?
Oh, in front of the...
In front of the natural log, right? So exponent can be brought down freely, and that just makes it where we can push that coefficient out, makes it a little bit easier to think about. So reset, I have it up here. That exponent 4 I brought down as a 4 in front. The left side is ready to go. The right side is a little messy. There's no rule that can handle this initially. We have to go through what? Yeah, use substitution, right? So if anything looks too complex for any rules that you see in front of you, you know you want to maybe consider use substitution. So what could be our u value? Yeah, the natural log of x. And the hope is that the natural log of x will take care of that x, which it should with the derivative. So we start there. Our u value is natural log of x. Our derivative is u prime over u. So natural log of x just becomes 1 over x. Okay. So we're going to step through our u substitution. Our u value is natural log of x. Our derivative, du dx, is 1 over x. Cross multiply. I get dx equals x du. I'm ready to replace the parts. Natural log of x gets replaced with u. The x is going to stay. Replace the dx with x du. And thankfully, the x's go away nicely. So I didn't do the integral of the left side yet. I wanted to wait till the right side is ready. So left side is a natural log rule. The right side is going to be what rule?
Just
power rule. Yeah, just power rule. So u becomes u squared over 2 plus c. Replace the u back in terms of x. And if we can get to this point, we've earned most of the points available here. The rest is cleanup. I'll pause here for a moment, make sure you guys can catch up. I took the 4 and the 2, I reduced it to be just 2. I replaced the u back in terms of x. So I'm now sitting at my function level at my original. I've taken care of my derivative level, moved it up to the function level, and now it's just a matter of solving for y. Okay, questions so far? Okay. There's no specific solution, so we don't have to solve for c. We can jump directly to solving for y. There's natural log involved, so we're going to have to use what? Base e. Yeah, base e will clear that left side out nicely, and we just have to work to get that right side cleaned up as well. So left side becomes just absolute value of y, because e and natural log take care of themselves. We can split this into the product of two bases, e to the a times e to the c. make sure you turn that plus in the exponent down to multiplication at the base level. And we can drop the e to the c and just let it be represented by a big C. Push the c out in front, drop the absolute value, plus or minus, get absorbed into the c. And we have our general equation. Question with 3. Okay, anybody still need to look at 3? All right, number 4. y prime minus 2e to the 3x equals 0. Go ahead and spend a minute to do the initial steps. Can you separate the variables down to the point where we're ready to take the integral? Okay, let's talk about the initial steps. That y prime, I'm going to rewrite as dy dx. I'm going to get it as a fraction. Get that 2e to the 3x to move to the right side of the equation. If it helps, put that over 1 to see what parts will combine as you do cross product. I want the y's on the, I want the dy on the left, the dx on the right. So initially it's just going to be y dy equals 2e to the 3x dx. Okay, our dy dx are in the right slots. Take a step back. Do we have anything else that needs to move? All right, so it's nice, right? We already have full separation. There's nothing left to move. I will say, though, that if there was a coefficient in front of the y, I would go ahead and divide that over. But the left is already as minimal as it can be, right? There's nothing we can do with the left side in terms of cleanup. So we're ready to go. After cross multiplying, there's no separation of variables needed. Questions so far? Good. Okay, the left side, we can apply what rule to take the integral? Just power rule, right? How about the right side?
It would be
E to the u, right? And there's a little bit of what going on. We got to keep track of our u substitution. Okay, but I want to talk about how if you have a simple u value, like a linear term, we can do a little bit of a shortcut. And I want to talk about the shortcut. If you're comfortable with it, you can apply it. But if not, you can still use u substitution, which I will show the steps for. But let's talk about that for a moment. We know that the u value is 3x because we know that's what we're going to work towards. But we can get to the point if you're comfortable, where we can jump from here to the antiderivative without having to write all those notations out. And I want to talk about that. We can do it for easy u values like 3x or 1/2 x or x over 2 or 5x. And here's the process. What's the derivative of 3x? Just 3, right? And normally, when you do chain rule, you would do e to the u times u prime. And you would just multiply it by 3. But the antiderivative is a little bit different, right? We still involve that 3, but instead of multiplying by 3, we're going to be dividing by 3. So we end up multiplying by the reciprocal. So if you can just think of that 3x as take the derivative and take the reciprocal and push that number out in front, that's going to be the leftover term. So if you're comfortable, you can do this right here. You know that e to the u is just going to stay e to the u, so I can say my antiderivative is 2 times that 3x will produce a 1/3, so 2 times 1/3 e to the 3x plus c. And if you can make that jump, you can save a bit of time, especially for the u substitution that are relatively simple. Okay, but I'll show the steps here. If you want to go through your substitution, that's fine as well. You'll let the u value be 3x. The derivative is du over dx is 3. Cross multiply, 3x equals du. dx equals du over 3. You make that substitution. But if you look, what happens, that 3x basically is just going to turn itself into a 1/3. And if you're comfortable making that jump, you can save a little bit of time. Okay, so we know integral of y will just be y squared over 2. The integral of 2e to the 3x would just be 2/3 e to the 3x plus c. And we accounted for that 3 by putting in the denominator of my coefficient. Okay, we've earned most of our points here. Any questions here? Now, we have to still solve for y, we still have to solve for c, but this is what I prefer. You don't have to do this, but I like to keep the left side as minimal as possible. So even if it's a small thing, like a divided by 2, I'm just going to take the time to just multiply it over to the right side. If I can keep the left side minimal, then it will save the cleanup effort down the road. So I'm going to take that 2 and distribute it, multiply through with a 2. Just so I can get this down to y squared, a little bit easier to think about with the y squared instead of dividing by 2. So if I distribute this through, I'll get y squared is equal to 4/3 e to 3x plus e times 2c. But we know 2c is just a constant, so we just let that 2 get absorbed into that c, and we'll start here with the cleanup step. All right. Now, I have to solve for c, but I've got to make that decision, right? Do I want to solve for y first? Do I want to solve for c first? It doesn't really matter which one you do first, but I like to go down the path where I have the least amount of messiness to deal with. So when I see y squared, first off, we don't involve e, right? There's no e involved here. We don't raise both sides with base e because there's no natural log to get rid of. But we do see a square root in our next step. And because there's a square root in the future, I don't want to deal with that c when it's stuck inside the square root. So because of that, that's guiding my decision to solve for c earlier to avoid the messiness of the square root. And then once I get that c resolved, then I can take the square root and that'll be my last step. So when I see that that exponent, that's going to cause me to want to solve for c earlier. Okay, so I'm going to take the 0, put in for the x, 5, put it in for the y. And I'm going to work to solve for c a little earlier than previous problem. So 5 squared becomes 25. 4/3 e to the 3 times 0. E to the 0 is just what? 1. That drops out. So I just subtract 4/3 from both sides to solve for C. 25 minus 4/3, use your calculator or common denominator. 75 minus 4/3 is 71/3. There's my C value. I'm going to update my C value. As I update my C value, now I can just take the square root, and I know that I'm done with the right side. There's nothing left I need to do except that square root. Okay, any questions up to this point? Now, when we take the square root, we have to be aware what's going to come out of it. Plus or minus. There's two solutions. There are two possible solutions, but only one of them is going to be the correct one, or only one of them is going to apply for our problem. So when you take the plus or minus, we're going to end up with a positive square root and a negative square root. And how do we decide between the positive and negative square root? Yep, look at the sign of the y value. Whatever the sign of the y value is the sign of your square root. If I have a positive 5, then I want to choose a positive square root. If I see a negative 5, then I want to choose a negative square root. Okay. Positive square root because our ordered pair has a y value of positive 5. Questions? Okay. Now let's circle back to number 1. And this is the one that we have to deal with, variable that we're not accustomed to seeing. Anybody still need this? Okay, all right, number 1. Okay, this is a free response question, but let's just focus on this differential equation. I'm going to solve this differential equation. All right, what's strange about this that we're not used to? Yeah, we're not used to B, we're not used to T, we prefer X's and Y's, right? Those are the comfortable variables. But what I want to talk about is that if you see a problem that's not X's and Y's, it's going to be restricted to a certain pattern, okay? And once you recognize that pattern, then you just have to make a slight adjustment, train your eyes to adjust to that pattern. The pattern is that if you see a word problem, it's always going to be time involved. It's always going to be in relation to time. And because of that, time is going to be the independent variable. So time t is basically your X variable. So if it's a word problem, it's always time with something else. In this case, B is the variable. That's the other variable. It could be N, it could be M, it could be Z. And so that's what throws students off. They see the strange variable and they just don't know how to work with it. But if you can think of it in terms of, if I see a strange variable, my time is my X and my strange variable is the Y. So just train your eyes just to adjust to that pattern. You want the T's on the right side and then the other variable on the left. So in this case, my B is my dependent variable. I want the B's on the left. I want the time T's on the right. Students have asked, can they rewrite the equation so that it's X's and Y's to make it more comfortable? I think that's fine. I just feel like you're losing some time when you do that, and that's an additional thing you got to keep track of in addition to all these other things you got to do. So I prefer that we just kind of train our eyes to know that, all right, if I see time, I'm just going to treat that like I would with X's. If I see a B or Z or a K or M, that's my Y variable. I'm going to put that on the left side. Okay. All right, so first things first, I'm going to try to, there's no need to rewrite my prime because it's already showing me my differential variables. But I do want to get this ready to cross multiply to make it a little bit cleaner. I'm going to put that 5 below the 100 minus B. And another thing to talk about is the parentheses is there to help you. Don't distribute the 1/5 through, because they are putting that 100 minus b together to help you. If you want to move it, that those things have to stay together. Okay. So I see my opportunity to cross multiply. I want my dB on the left, I want dt on the right, and those are the first two things I want to set in place. So I'll say 5 dB is equal to parentheses 100 minus b dt. So my first order of business, get my differential variables in their right slots. At least I have those things set, anchored down. And then I can now worry about, okay, is there anything else I need to move after that? What do you see?
The B inside the parentheses.
Okay. But if we move the b, we got to move everything inside the parentheses. So the 100 minus b, you have to divide over. So this is going to come to the denominator on the left side. There's something else that I would like to move, but not completely necessary, but I think it's helpful. Yeah, the 5. I like to leave the left side as minimal as possible. The 100 minus b has to be on the left. I can't move that 100. I mean, I can't leave that 100 on the left side, on the right side, I mean. But the 5 I can move over. So I'm going to make both of these kind of swap places. Yeah, take some time to get used to, right? Because we're not used to seeing those variables there. But that's our y and that's our x. We have full separation of variables. I'm going to get both sides ready for my integral rule. Now, to make it a little easier to read the right side, I'm going to push the 5 out as 1/5. I'll put a 1 in front of the dt to make it easier for us to see what's going to happen afterwards. The right side is easy. The left side, we got to go through a little bit of what? Yeah, u substitution. What's our u value? Yeah, it's an entire denominator. We're going to be targeting the 1/u rule here. Okay, so a little bit of u substitution here. Instead of du over dx, now it's du over db, just -1. Replace my variables in terms of u, so I have -1 du over u. That's just natural log. And I'm going to replace the u back in terms of b. I'm going to reset, bring this up to the top. Or actually, let's solve the right side as well. What is 1 dt going to turn into?
Just t.
Good, right? So if it's 1 dx, it'll turn to x. 1 dt, that's telling us our variable is t, so we're going to make our 1 turn into make it rise to a degree 1 for t. Okay, so here's my left side, here's my right side. I'm going to reset, put this above here. Okay, it's a little messy with the cleanup process, but the good thing is we've earned most of the points. We've done the calculus. We separate the variables. The rest is just a little bit of cleanup. Okay. Okay, so here's what's a little strange here. I would like to solve for b first because I see natural log, and I'll save the c for the end. So what can we do? Yeah, but there's something, this is a little odd here, something that is out of place.
Oh, we can move the negative.
Yeah, that negative is causing things to be not quite ready. So I'll just multiply everything through by negative. to move that negative over. And that's, yeah, that's kind of tough to see, I know. Makes it a little messy. We're going to change the sign of the 1/5 t, but the c will still remain plus c. We know plus c just represents all positive and negatives. We're not going to make it a minus c. Okay, now we can do base e. Okay, yeah, so that slight adjustment makes it difficult to see. Okay, left side cleans up. Absolute value of 100 minus b. Right side, clean that up. E to the c, we know it's just can be replaced with a big C. So I just want to just talk about this for a moment here. Is on the AP exam, when you get to this point and you're stressing out because you feel like you got to do so many things just to clean it up, just rest assured that, you know, try your best, but know that it's just like 1 or 2 points. It's probably just like 1 point. It's not, this is not the focus of the problem. If you get to this point, this is it. This is what's most important. If you get to that point, you've earned the points necessary, and the rest is just bonus. If you can get those points, great. If not, you know, you're not going to lose any sleep over that. Okay, but yeah, I can see how this is messy, right? It's just kind of an ugly process. We can drop the absolute value, let the C absorb the plus or minus. The plus or minus goes away. And I want to rearrange this with the B being positive. So I want to get B is equal to 100 minus CE to the negative 1/3 t. You see how I'm just going to rearrange it just to solve for B by itself. So okay, from here, we have a general equation. We can move to our specific equation by putting in 0 in for T and 20 in for B, and then solving for C. Okay, the nice thing is at least the T is 0. Okay. So what's C equal to? Yeah, negative 80. This is most of our time is spent on cleaning up here. Okay. Yeah. Don't stress out over this. What I'm most concerned about is this part right here. Can you do the separation of variables? Can you get to this point? The rest is nice, but it's not the focus. Okay, just a couple of reminders. Chapter 4 recovery assignment is due tomorrow. I created a Teams assignment. I also made a couple of help session videos under yesterday's date. So as you're doing test corrections, you can watch the video to help you with I worked similar problems as the test. And chapter 4 recovery test is on Monday. You got to choose between either 7:15 or 4:30. So you need to email me or send me a text remind if you want to choose one of those time slots. And then the test for chapter 5 and 6 is now going to be Thursday. Okay, we'll have tomorrow we'll do inverse trig. That's our last new topic, and then we'll spend Monday through Wednesday reviewing all the things that we've done with chapters 5 and 6. Okay, I entered in your quiz grade. Most of you guys did pretty well, but I will hand those back by Monday so we can review them. All right, thanks everyone. Hope you guys have a great day.